how do we compute the indefinite integral of the secant function? There are many different ways to go about this. Well, as you know, this is quite common for integration. I'm going to show you the way that is the most intuitive and easy to remember, but not by rote memorization, so that you can derive the so-called integration formula in just a few seconds whenever you need it to solve some other problems. But there are no tables of integrals around. To start with, let's grab the fundamental pair of trigonometric functions that is associated with the integrand here, secant and tangent. Remember, these two guys come in pair because of the identity, 1 plus tangent square equals secant square. But then what should we do with them exactly? Well, when we do integration, we're fundamentally relying on derivatives, so why don't we see what their differentials are? The two functions often comes in pair in different occasions. Their differentials might relate with each other in some way. So when you differentiate secant, you get back not only secant, but also its partner tangent in addition. And when you differentiate tangent, you get its partner secant twice. So here are the two differentials we want to investigate. Now, if we add them together, the left-hand sides can be combined into one single differential, d secant x plus tangent x. Then, on the right-hand sides, we have a common factor, secant. So adding up the right-hand sides, we have secant x times secant x plus tangent x and dx. That looks quite promising to me because I see secant plus tangent and its differential in the same line. Probably we should collect them on one side to see what happens. Now here is the nice thing. Without too much effort, we get back what we're originally after on the left. Not exactly the same, but in the differential form, secant x dx. Integrating both sides, that tells us exactly how to integrate secant. Look at the right-hand side. It's just like integrating 1 over u, whose antiderivative is the familiar ln of u. So, congratulations. The indefinite integral of secant of x is ln of absolute value of secant of x plus tangent of x, in addition to an arbitrary constant. As a quick reminder, the absolute value is necessary here because the domain of ln is positive, but secant x plus tangent x takes positive and negative values alternately over the real line. So, over those intervals where the value is negative, only ln of the negative of secant plus tangent can be a legitimate antiderivative of 1 over secant plus tangent. That's all for solving the problem indeed. But just a quick note here. You might have come across the problem that asks you to show the result instead. If that's the case, chances are you were also given the hint that you should multiply the integrand by secant plus tangent over secant plus tangent, and magic would happen. To most of the people, this is really like something out of the blue. But now, if you recall what we just discovered after combining the differentials of the fundamental pair, you should see why you were given such a mysterious hint. Alright, that's it for this video. I hope you enjoy it, and I'll see you in the next one.